Welcome back, welcome back, welcome back. I'm Lisa Blackburn, and this is my YouTube channel for everything I want to talk about, science and math. And today we're in honors chemistry class learning about the foundations of chemistry. So chemistry measurement and stuff like that. Okay, there you go. All right, so if y'all are going to follow along in your guided notes, let me get mine. And then, anyway, so then I stopped having such good quality in my videos, didn't worry about it so much anymore. Oh, there's Unit 2. Unit 2. And now I have things like this where I wander out of the screen. So, but still, I got lots of followers. Got about 850 followers. And chemistry, you know what, there we go. And but I don't make you money yet. I need 1,000. So like, share, subscribe. There you go. Mash that subscribe button. Okay, where's my little pen here? On SB Moen, he says, we'd whack that subscribe button. Okay, so what do you think the answer is here? Is the study of substances and the changes they undergo. What do you think that blank is? Chemistry. That's what we're here for. So chemistry is the study of the substances and the changes they undergo. So we have measurements in chemistry, otherwise we're just having fun if we don't measure things. And there's two kinds. They both start with a Q. What are they? Y'all learned this before in math class? Yes. Measurements that are descriptive and non-numeric are called qualitative. Now, does this sound familiar? They are qualitative. If the results are in a definite form, usually numbers, they are called quantitative. Now, does it sound familiar? Okay, and also full disclosure here, I'm slightly dyslexic, so if I start writing backwards, let me know. It won't hurt my feelings. I already know I'm dyslexic, you know, so if I just start writing backwards, usually I catch myself. I do it more if I'm stressed. But one time I was teaching chemistry at that old school, and I wrote a note to my co-chemistry teacher, and I wrote on it that I made the keys for the test. I set up the lab. The chemicals were in the hood, and she could send a student for the chemicals, but she had to come get the keys to the test. Ha ha. I had the little note, sent it to her. She comes running in, lab coat flapping, looking mad at me with the note in her hand. And she's like, and I'm like, why are you mad at me? I did all the work. I made the lab. I made the keys. Why are you mad at me? And she says, this some sort of joke? And I'm like, no, the chemicals are in the hood. Here are the keys to the final. I'm like, what is your problem? And then she just busted out laughing and said, you're dyslexic. And I'm like, oh, how does it show? And the note, I'd written the whole thing in perfect mirror writing. So like if you had, but to me it looked totally normal. And then I blinked and I could see that it was backwards. But I had written the whole thing, just perfect mirror writing without even realizing it. So if I start mirror writing, I haven't fallen into the looking glass. I'm just dyslexic. So, but see, look, you can overcome learning differences and still be successful. Okay, so good measurements. We want to make good measurements in here. We're going to do lots of labs. You're going to love it. We want lab measurements that are accurate and precise. Now, what's the difference? Accuracy is how close a measurement comes to the truth. How close it is to the truth. Precision is how close several measurements are to the same value, or how finely stated they are. How many decimal points do you go to? You want ones that are more finely stated if possible. Of course, you don't want to make up numbers. Okay, so how repeatable it is also. All right, so this. Here, I've got 3 arrows I shot close together, but not at the bullseye. Is it accurate? No. Is it precise? Yes, because I hit the same place. So this one is precise. We'll just put a P for precise. Okay? How about this one? Is it accurate? Yeah. Not really. I got one accurate, but overall, if I averaged them, they wouldn't be very accurate, would they? Is it precise? No. So this one is, it's got mixed accuracy, but it is not precise. It's not P and sort of mixed accuracy. Okay, how about that one? Yes, it's precise because we hit the same place 3 times, and it is accurate because we hit the bullseye. So that's what we want in science, and you need to know the difference in those. Okay, can I go on? Am I going too fast if I go on? Okay, let's also talk about your notes. You have to color them. Now, you're like, why in the world do I have to color, Miss Blackburn? It's because everything I do, believe it or not, is research-based. And research shows that guided notes improve student achievement on all ability groups. So it really helps the real low kids who are in special ed. It helps the medium kids. And guess what? It even helps the honors kids to have guided notes, studies show. And studies also show that for most people, if you color the notes, it will help you remember because it will help link the visual into your brain. So it'll help you have visual recall on the test. So I don't care what color you color it, but I take off 3 points off of your packet if you don't color your notes. 3 easy points. Do a little coloring. That's why I told you to pick up colors on the way.
By the way, if it bleeds through, do we lose points?
No.
Got it.
Just make it, if you make it where you can't read the notes, I'll probably take off because I'll be like, what is this mess? But otherwise, this is just to make you learn. Formative is all about getting the information to you. Okay, so how do we express measurements? One thing we use is scientific notation. It's a way to write really big and really small. Oops, why are you not? Oh, it's because my sleeve touched it. Really small numbers. Now, why do we do this? For one, it's easier. And for the other, it's because of our calculators. Our calculators can do math on bigger and smaller numbers than the display can hold. So we needed some way to tell our calculator this number so it can do the math for us. So one of the things you have to have in this class is a scientific calculator that can do scientific notation. You can't just have a Dollar Tree calculator. It's got to have a button that makes it where we can do scientific notation. I'm going to show you how to do it. Now, I teach this in my math classes that I've taught in the past. I don't think they do here. So if you don't know it, don't worry. If you do, good. Okay, so this is how it works. Here's a big number. And first of all, there's a little bit of etiquette to it. And the proper way to write a number in scientific notation is you write one non-zero number shown by X, just like in math class. And then any other non-zero numbers, and then times. And I know normally in high school we don't use X for times anymore. We use a dot or parentheses or a number next to a letter. But in this, we use an X times the number 10 to an exponent. And I'm going to put EXP for exponent. Okay, so if you have your calculator, get it out, and you can do this along with me. You should always have your calculator, your notebook, your chemistry stuff out, so hopefully you already got it out. If not, don't worry. You got a worksheet on this, and you'll have plenty of time to practice it. So that's how it works. So there is a decimal understood to be right there. What we do is we frog hop the decimal to its proper place. So it's got to go right behind the 1. So we hop it over there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 frog hops. Does everybody see how that was 10 frog hops to get there? So now we write the number 1.23 times 10 to the 10th power. Okay, how do we feel about that? Okay, so here's a small number. We do the same thing. We take our decimal and frog hop it to its proper place behind the first non-zero digit. 1, 2, 3, 4, 5, 6. So this is 1.23 times 10. And because it's a small number, it's -6. Ta-da! Feeling okay about this so far? Not too hard? Okay, let's go on. Can I scroll all the way down to the next page? Anybody need me to wait a second? Okay. All right. So a big number has a positive or negative exponent. You just saw it. Did the big number have a positive or negative exponent? Positive. Small number, positive or negative exponent? Negative. Okay. So on your calculator, what you're looking for is a button that says EE, EXP, SCI, or times 10. So you can show me your calculator if you're not sure if it's the right kind, but it's got to have one of those. So E, or just the letter E, means times 10 on your calculator. When calculators were new, they could only do things on a rectangle cut in half. So like a rectangle cut in half was an 8, a rectangle was a 0. You understand how it works, how the display was? It couldn't do an X, but it could do the letter E for exponent. So that's why E means times 10. So if we were going to put this number in our calculator, first of all, we're going to put it in scientific notation. So 1, 2, 3, 4 frog hops. This is 3.6 times 10 to the 4th power. Okay? Everybody got that? So on your calculator, we're going to put this number in. Let me get my calculator. This is the calculator I recommend you get, the TI-84. So you turn it on right down here. And you clear out anything that's in there with the clear button. And I'm going to put in this number on my calculator. And if you got your calculator, give it a try. I'm going to put 3.6. See the point down there? Then the EE button on this one is painted on the calculator behind the comma. So I do second comma, and that gives me a little E. That E means times 10, so I don't do times and I don't do 10. E means times 10, and then I put 4. And that's the number in the calculator. Now, would it work if I did 3.6 times 10 up arrow to the 4th power? Sometimes yes, but sometimes no. So I want you to get in the habit of always putting scientific numbers in your calculator, because it'll work for you one day, but then when you're doing the test, it's not going to work for you, and you're going to get it wrong, and you'll be like, what did I do wrong? And I can't explain to you why the calculator does it wrong sometimes. It's because the calculator, if I put it in my oh, and let me tell you this. The display looks like this. 3.6 E4. That is that in the calculator. Okay, so let me explain it to you. Your calculator sees remember terms in algebra? Remember the terms? X2 is a term. 3x squared is a term. Remember that part of algebra? Nod if you're with me. Yes. Okay, good. All right. Your calculator sees this as 2 terms. 3.6 and 10 to the 4th. Your calculator sees that as 1 term. You want your calculator to see things as 1 term, or else sometimes if you don't use enough parentheses or whatever, your calculator will be doing the math you want it to do, but only to one of these and not the other. And that's how you get the wrong answer. If that did not make sense to you, don't worry, it's not important. What's important is that you put your numbers in scientific notation when I tell you to. Okay? All right, so let's try this one. So 200, the decimal's right here, 1, 2. So this is 2 times 10 to the 2nd power. On my calculator, it is 2E2. And then I can multiply them. So I got that first number in my calculator. I'm going to hit times. I'm going to put in my second one, 2 EE2 and get the answer. Anybody doing it? Anybody playing along in your calculator? You don't need to be doing this. It's one level of skill to watch me do it. It's a whole different level of skill for you to do it. Okay, so the answer that came up on my calculator was 7, 2, 1, 2, 3, 4, 5. And if I put that in scientific notation, 1, 2, 3, 4, 5, 6, that's the same thing as 7 times 10 to the 6th power. Isn't this fun? We're doing math. Don't you love math? Math is great. That's one of my slogans on my YouTube channel. Math is great. Okay. All right, y'all ready to move on? Feeling all right about this? This is not too hard, is it? All right. So let's try this one. Put this one in our calculator. First, we got to find out what it is in scientific notation. 1, 2, 3, 4, 5, 6, 7. So this is 3.3 times 10 to the negative 7th. I put it on my calculator. 3.3 second EE negative. The little negative sign's right down here on the bottom, not minus. You'll get an error on your calculator. It's negative 7. So on your calculator, make sure you know where the negative button is. So this one, 1, 2, 3, 4 times 10 to the negative 3rd. I'm going to divide them. So I'm going to say divided by 4, negative 3. And the answer I got was 8.2 times 10 to the negative 5th. But on my calculator, it looks, 8.25. I left off the 5. Oh, that's messy. The answer I got on my calculator says 8.25 E negative 5. And those are the same thing. You have to write it like this, not like that. Okay? Feeling groovy? All right. Significant figures or significant digits. We're moving on to our next topic. Remember I told you, lightning fast. If you can't read that, that's 8.25. I left off the 5. Significant figures or significant digits, we also call these sig figs or sig digs because we're nerds. It might be a shock to you, but science and math people are sometimes nerdy. I know you thought we were the cool ones, but sometimes we are the nerdy ones. And nerdy people use unnecessary acronyms and abbreviations and letters. So sig figs, sig digs, just because we're cool like that. All right, so why do you have this? It's because of this. You do math on your calculator, and it gives you a billion decimal points. Say you do 2 divided by 3 on your calculator. You're going to get 0.6666667, right? Everybody's done this on your calculator? All right. So how many of these do you write down? That's the question. Well, in science, we can't write down too many, or we're lying. What do you mean we're lying? We're lying, we're making it look like our lab equipment is better than it is, and it's measuring to more decimal places than it does. We have cheap lab equipment. We have 3 little balances around the room. I think they read to the 10th, or maybe they can read to the 100th, but that's it. They certainly don't go as far as your calculator can go. So we have to make sure that our numbers reflect our measurements. Does that make sense to you now? Okay. Y'all are really quiet. Y'all aren't giving me much feedback here. I'm just going to assume you got it unless you stop me. All right, so how to round. Now, how you round is 5 and up rounds up. And you're like, I have known that since 3rd grade, Miss Blackburn. Weirdly, there used to be more rules than this in chemistry. So I'm telling you the rules you're going to follow. And if you ever see the other rules, just say, oh yeah, Miss Blackburn told me that there were some other rules that had to do with odd and even and stuff like that. I'm not going to tell you about it because it might confuse you. Just 5 and up rounds up, 4 and down rounds down. And the next thing is you only look at the digit next to the place you're rounding it to decide. Now this is taught wrong in a curriculum. There is a curriculum used in private schools and homeschools that you might have used. A lot of times my honors kids have been to private school or homeschool, and there's a curriculum that has it where you look at starting at the end. Let me explain to you what I mean. What do I mean? Sorry about you people in YouTube land I'm erasing the board right now, just so you know what's going on and you don't feel left out. All right, so here's a number. 2.3791624. Okay, so the right way to do it, if I needed to round to the 10th place, is I only look at the 7. 7 is bigger than 5, so it rounds up. The answer is 2.4. Okay. The wrong curriculum says you start at the very end of the number and go all the way down to see what happens. 4 leaves the 5 alone, 5 rounds the 2 up to 3, 2 leaves the 6 alone, 6 rounds the 1 up to 2, 2 rounds the 9 up to 10, which makes this an 8. It wouldn't change this one, but sometimes it does. You don't do this. Why don't you do that? Was anybody taught that at any point in your life? Okay, good. The reason why you don't do it is because these numbers have real meaning, and this way little bitty number is too small to have any power on this giant tenth. That's a tenth, that's 100, that's 1,000th, that's a 10,000th, that's 100,000, that's a millionth, that's a 10 millionth, that's 100 millionth. Imagine 100 millionth, that fraction of anything. Can you see how that's too small to have an impact on a great big tenth? A tenth of a cake is a nice big piece. 100 millionth is none. You're getting no cake. Does that make sense to you? Okay. All right. Moving right along. Okay. Next, why do we do significant figures? Is we want to be honest scientists. Remember I told you it's a way of lying? And not make our data or data. Some of y'all say. I say data. I had a student from California last semester and he's like, no, Miss Blackburn, it's data. Okay. Make it look better than it really is. So how do you do this? You do your math using all, and I'm going to write this in all caps so you don't forget. You don't worry about significant figures to the very end. You do the math in your calculator using all the digits you have. Then, there's different rules whether or not it's adding and subtracting or multiplying and dividing, okay? If it is adding and subtracting, you round your answer to the same number of decimal places and the number with the least decimal places. Oops, my sleeve's getting in the way again. They're supposed to be replacing these with boards that don't do that. We'll see. It was in my science teacher meeting for the county. All right. That probably sounds like gobbledygook for you. Don't worry about it right now. We're going to be doing a worksheet in a minute. It will make more sense, okay? Multiplication and division. This is more normal in chemistry class. We do more multiplying and dividing than we do adding and subtracting. We do a little, but more of this. Round your answer so that your answer has the same number of significant figures as the number with the least number of significant figures. There are rules to knowing what the significant figures are. Remember the don't panic part because I'm going fast here. Just, we're going to be okay. Okay, here's the rules. All non-zero digits are significant. So this number, 1, 2, 3, 4, 5, has 5 significant figures. It has 5 numbers that aren't 0. Does that make sense to everybody? Okay. So the problem is zeros. Do you count zeros or not? Sometimes yes, sometimes no. Here are the rules. Zeros between non-zero digits are significant. Do you see how the 0 is between the 1 and the 2? So this has 3 significant figures. Zeros in the middle count. Okay. The next one, zeros that start a number with a decimal are not significant. So 0.002 has 1 significant figure. Zeros at the beginning don't count. So let's review. Anything that's not 0 counts. Zeros in the middle count. Zeros at the beginning don't count. Good so far? Okay, let's go on. Zeros at the end of a number after a decimal count. They are significant. So 1, 2, 3, 0, 0, 0 has 6 significant figures. Zeros at the end count. Non-zeros count. Zeros in the middle count. Zeros at the beginning don't count. Zeros at the end after a decimal count. Good? Okay, last rule. Zeros at the end of the number with no decimal are not significant. So 4,200 has 2. Zeros at the end with no decimal don't count. All right. It'll make more sense. See, don't worry. Once you practice it, it will be easy. We're going to do it. That's one of your things you picked up today was a worksheet on this. All right. Change between measurements. This is so important. This is one of the most important ideas in chemistry. You will do it from now until you stop doing chemistry. Okay? And that's changing between measurements. Okay? So this is called factor label. It's also called dimensional analysis, which sounds so fancy. When your mom asks you today, what did you learn today? Say, oh, dimensional analysis in chemistry. It was easy. And you'll sound so smart. See? That's fun, right? So how we do this is by using conversion factors. Conversion factors equal 1. Okay, so this is the reason why some of y'all are those kids who always have to know why to learn anything. This is why it works. Mathematically, anything times 1 is itself. 6 times 1 is 6. A billion times 1 is a billion, right? Second math idea. Anything that's the same in the numerator and denominator equals 1. 3 divided by 3 is 1. A billion divided by a billion is 1, right? So what we're going to do is we're going to use this principle to change numbers to a different unit without changing their value. If you don't care about that, you could just delete everything I just said. It's not important, but that's why it works. Okay. So we want to say how many seconds are there until break? Well, or do you all consider break Friday when DLD, or do you consider Monday, MLK Day itself? What are we going to count to? So today's Wednesday, Thursday, Friday. We'll just go to Friday, okay? We'll say it's 2 days until break. Everybody okay with that? And we want to know how many seconds are in 2 days. Well, I don't know that off the top of my head. So we're going to figure it out. Okay, so how you do these problems is you always start by writing down what you know. Okay, now why'd I go no? Okay, so one of the ways I teach science and math is by teaching you hand signals. I make you color for you visual learners, and I make you do hand signals for you kinesthetic learners, you people who like, if you put a movement to something, it helps you remember it. So so we always start with what we know. Okay, so when I do this, y'all say no. You ready? That's your part. We always start with what we... That was very weak. Let's try it again. We always start with what we know. That's right. We start with what we know. So we write it down. 2 days. Now, here we have a choice. We could use fraction bars and parentheses, or we can use what's called train tracks. I say you use train tracks because I'm old. I know it shocks you. You thought I was 22, but I'm not. And in my decades of teaching, I have seen kids turn parentheses into sixes and get their answer wrong. Breaks my heart. So we don't use parentheses, we use train tracks, and nobody turns it into a 6. So this is what I mean by train tracks. So this is our fraction bar, this is the numerator land, and that's the denominator land. After you write it, you take what's in the numerator, just the units, and you push it catty corner down to the denominator. It's more fun with sound effects. So go. Okay, so everybody in your brain, we're going to push the days down to the denominator. Okay, now we think, is there something that I know how many seconds are in a day? I do not. But I do know how many hours are in a day, and 24 hours is the same thing as 1 day. So this equals 1 because the numerator and denominator are the same. If I multiply this by 1, I have not changed the value. I keep my train tracks going. So now I take what's in the numerator and I push it to the denominator with sound effects. I put my hours down here, and I still don't know how many seconds are in an hour, but I do know how many minutes are in an hour, and that 60 minutes equals 1 hour. Then, now I'm going somewhere. Minutes go to the denominator, and I know that there are 60 seconds in 1 minute. If you have the same thing in the numerator and denominator in math, what do you get to do to it? Cancel it. One of my favorite parts of math. I know it's not logical, but there is something extremely satisfying about marking out math. I don't know why, it just is. It's like popping bubble wrap. Okay, so days cancel out, hours cancel out, minutes cancel out, and I'm left with the unit I want, seconds. Hooray! Okay, now I do the math. Any number on top you multiply, any number on bottom you divide. If it's a 1, you can skip it because anything multiplied or divided by 1 is itself, right? The identity property, remember those properties from math? Okay, so on your calculator, you do 2 times 24 times 60 times 60. Does anybody have their calculator out and want to do the math for us? I do. 2 times 24 times 60 times 60 equals 1, 7. Oops, that's very bad. That's what I said. I should look where I'm writing. Okay. 172800 seconds. Okay, after you do a math problem, you put a box around it. Ta-da! Why do you put a box around it? Because I used to teach bad kids in Cobb County, and they would cheat by doing problems every possible way. I'm sure you good Paulding County kids have never thought of that. But like if they didn't know what to do, they would add, subtract, multiply, and divide the numbers in every way possible. And then it was all over the paper, and then I'd mark it wrong, and they go, but the right answer was here, but yes, so were 10 wrong answers. You got to decide on one and put a box around it. Okay, so let's try another one. What do we start with? What we know. And we know, what we know is this, 4 feet. And we want to know how many centimeters are in 4 feet. What do I do with the feet? Push it to the denominator. Do I know how many centimeters are in a foot? No, but I do know that there are 12 inches in a foot. Push the inches to the denominator, ka-chow. And I know, you might not, but I know that there's 2.54 centimeters in 1 inch. Feet mark out, inches mark out, and we can do the math. More fun with sound effects. 4 times 12 times 2.54, and we get 121.92 centimeters. Put a box around it. All right, we'll do a lot of that. You'll get better at it. I'll teach you how to use your calculator if it's in the denominator, if there's numbers that aren't one in the denominator. But that's the gist of it. How do we feel about that? Good? Moving right along. Oh, okay, so I have this really cute Kermit the Frog sweatshirt, and I want to embroider something on it, so it's science-y, so I could wear it to school, and I got to think of something that's science-y that goes with Kermit the Frog. So if y'all think of something, let me know, because I could embroider it on it. I could do moving right along, because, you know, that's a Kermit the Frog thing, but it's not all that science-y. Okay. International measurements. Next idea.
Technically, moving right along could be a metaphor for evolution or
kinetic energy. KE. I could do KE equals mass times acceleration. Okay, back on topic. In science class, we use measurements that can be understood. Get my elbow out of the way. Come on, let me write. Let's go up one and see if he'll be better about it. Come on. Oh, and let me write there. It's not letting me write there. Let's try writing over here a little bit more. Let's try scrolling and see if that helps it. Nope. Let's try going big again. Let me do it over here. Sometimes they'll straighten it out. I understand why they want to replace these things, but I like them okay. Oh, here we go. Oh, I'm pretty bad writing with the cursor. Well, I'm going to do this word and we'll see if it works. It's like magic mirror. Woohoo! Okay, in science class we use measurements that can be understood all over the world. I told you all my kids are in college right now, And the oldest, Nathan, he's at Georgia Tech in the PhD program. He's getting his doctorate in chemistry. Very proud of him. And he will sit there and watch videos of people in India doing chemistry, and they are not speaking English, and he doesn't know Punjabi or any of those Indian languages. But because they are using the international measurements and the elements from the periodic table, he doesn't need their words. He can understand the science they're writing on the board. Does that make sense to you? So that's why we have to use these measurements that can be understood all over the world easier. So it's called Le Système International des Units. I'm sure I said that in perfect French. But because we don't speak French, we call it SI. Oh, you're still not going to let me write. Hold on, I'm going to close this out and open it back up and see if it will be good for me.
SI.
Okay, let's see if it's going to let me write. Okay. Keep my elbow away from it. Ooh, it's letting me write. Yay. Okay, so we call it SI. Or sometimes we just call it the metric system. It's not exactly right. It's very close to the metric system, but it's close enough. We'll call it metric system. And the other measurement system you're familiar with is the English system. So foot, pounds, Fahrenheit degrees are all English. Meters, grams, kilometers are all metric or SI. So you have been in school a long time taking science class, so I bet you already know these. What is the SI unit of length? Not feet, but starts with an M, meters, that's right. So see if you can answer these before I do. The symbol for meter is lowercase m. Okay, how about mass? What do we measure mass in science? Not pounds, but grams or kilograms. We're going to say gram. Symbol being lowercase g. Time is the same. In science class, we measure things in seconds. Lowercase s. Current is in amperes. And we use this in English too. Like maybe you talk about amps with your stereo system. You've heard that before. That's short for ampere. I'm not going to go through all the abbreviations right now. Temperature in SI is in Kelvin. You probably never heard of Kelvin before, but we'll use it when we get to the gas laws chapter. And it's also Celsius. And this is one area that's Celsius. And metric is different, and we'll mostly use Celsius, we'll use Kelvin in one chapter. Volume in science is measured in liters or cubic meters. And 1 cubic meter equals one cubic centimeter equals 1 milliliter. You need to memorize that. That's a test question. Okay, a CC, if you're watching a drama and it's a hospital drama, they say, give them 100 cc stat of epinephrine in the heart because it's Jack Bauer and he's dead again. Got it. Give him some heart medicine. That's the same thing as in science class, which would be 100 milliliters. Nurses, doctors use cc's. We usually use milliliters. Energy is in joules, and it's not spelt like a diamond. It's spelt this way. Pressure has a bunch of units. We'll write a couple of them down. One is called a Pascal, which I like that. One is millimeters of mercury, so it's little m, big H, little g. And also atmospheres. ATM is atmospheres. Okay, now why do we like the metric system for science class is some conversions are easier. Some of it's not all that convenient. I think for cooking, English is better. If you watch the Great British Bake Show, every time they go to make something, they have to get out a scale and shake the big old flour into the little bowl. And then they got too much and they're putting a little back. I think it's much easier to get a cup, put it in. Another cup, put it in. Watch them at the beginning of their recipes. They're very slow and awkward, where we, who use cups and stuff, are much quicker. So, but I think for some things, in science class it's easier. I think in everyday living, the English system is great. Okay, so this is why it's easier is because of this. So King Henry's daughter bakes delicious chocolate muffins. So everybody imagine King Henry. And for his daughter, we are imagining the princess from Princess and the Frog. Everybody got her in your head? Okay, because we need a frog in this. So we got a frog too. So we got the king, we got the daughter, we got the frog. Okay, everybody's got the characters in your head. So you're gonna have this. So King Henry's daughter bakes delicious chocolate muffins. King is kilo. H is hecto. Oh, that's a bad T. Hecto. D is deca. B is basic. D is deci. C is centi. M is milli. So these are the prefixes we can add to the root to get our number. It'll make sense in a second. For example, if we want to change 4,800 kilometers to millimeters, we don't have to use train tracks. We can use King Henry's daughter bakes delicious chocolate muffins. So what you do is you start with where you are, which is at kilo, and you go to where you want to go to milli, and you count the frog hops. Remember I told you you needed a frog? So we got a frog. So our frog prince now is going to hop from kilo to milli. 1, 2, 3, 4, 5, 6 times that away. Everybody got in your head? 6 hops that away. So we take our decimal point, he's our frog, and we're going to make him hop 6 times that away. 1, 2, 3, 4, 5, 6. Where there are these hops and nothing, we augment zeros. Remember that from long division, augmenting zeros? That means you just feel free to throw a 0 down there. So I'm going to put 0, 0, 0, 0, 0, 0. So now I've got the number. It's 4800, 1, 2, 3, 6 millimeters. All right. Was that easier than train tracks? I think so. Let's do another one. We're going to change 6 liters to centiliters. I'm going to change my color. I think you should too, so that makes more, so it's less messy. So I start with what I know, liter. So basic is, we'll go all the way up here. Liters, meters, Celsius degrees, grams, whatever your root is basic. So I'm starting at the root going to centi. 1, 2 frog hops that away. 1, 2 frog hops that way. It's 600 centiliters. Ready for another one? I'm going to change colors again. We'll go blue. Okay, so this time I'm starting at milli going to deca, big D. Notice deci is little d, big D is deca. So I'm at centi, I'm at milli going to deca. I'm starting here and going to there. 1, 2, 3, 4 hops this way. So this time I take my thing and go 4 hops this way. 1, 2, 3, 4. So the answer is 67.9000 DG. Decagrams. Once again, you're going to do a worksheet practicing this, it'll get easier. Remember the lightning fast part. Okay? Feeling a little bit okay about this? See, some of you, every bit of this has been easy. And what I'm doing is multiplying my knowledge. So now I understand it, and some of y'all understand everything I've done perfectly, and now you can help your lab partner who doesn't understand it. And I'm multiplying my knowledge throughout the room. Because it started with just me knowing this stuff, and now y'all are starting to know it. And then some of y'all know it a little bit. Okay, so one of the first things we're going to do we have to have some math to practice. So density is a physical property of chemicals. And so our first little math thing we're going to learn is about density. So the formula for density is mass divided by volume. And here is a problem we're going to do. Okay, so our problems in here are usually word problems. Yay, we love word problems, right? But word problems can be tricky. What makes word problems hard? The words or the math? Is it the words or the math? The words. Because the math you're going to put in your calculator, and it's going to do it for you. You just got to put the right things in your calculator by understanding the words. So as we read a word problem, we're going to annotate it. You learned that in literature class, right? So first, we're going to mark it up. The question word goes with density, so I know that density is what I'm looking for. So by density, I'm going to put a question mark. What is the density of a piece of lead? Lead is a chemical that might be important, so I'm going to circle it. That has a mass, there's the mass of 114 and a volume of 10 milliliters. So for next, I'm going to list the knowns and unknowns. So what I don't know is, I don't know what density is. I do know what mass equals. It's 114 grams. I do know what the volume is. It's 10 milliliters, okay? Okay, and lead, I've decided now is unimportant. It might be important later. Next, I think of a formula. Is there a formula that relates density, mass, and volume? Why, yes, there is. It is density equals mass over volume. And I write it down every time. Every time write your formula down. That's going to help you memorize the formulas. Okay, then I put the numbers in for the letters and substitute them. When I do this, I sing a song. Now, you can actually do math without singing or dancing, but it's not as fun. So you should do it too. So the song I sing is Substitute. Is from before your time because it's before my time. It's a band called The Who from the 60s, and it goes like this. Substitute. So now we sing the little song, Substitute. Okay, and then we do it. So D, I'm going to leave as a D, because remember, things we don't know in math, we let be a letter, right? So this is D. Now I substitute in for mass, 114, I read that backwards, y'all didn't notice, whoop, 114 grams over 10 milliliters. Then you do the math. So that's equal, I can do it on my calculator, but this one is easy enough, I can do it in my head. 11.4 grams per milliliter. I'll put a box around it. Okay, couple of things about math. I'm very picky. One is you must have flat fraction bars. Do not write fraction bars like a slash, because once again, not 22, and in my decades of teaching, I've seen kids turn 1/2 into 112 and get it wrong. They'll forget. Some of the problems we'll do will take a whole piece of paper. By the end of all that math, you forgot what you were doing, and you'll put it in your calculator wrong. So no, only flat fraction bars, except in your units, you can use a slash if you want for divide. Okay, just little rules there. All right, next idea. Yay, we're doing great. Go us.
And I think a lot of people know who is. They did Bob O'Reilly.
Oh,
You know, Teenage Witch.
Yep, that's true, The Who. Pete Townsend. Okay, measuring moles. Okay, so moles is a unit we use in chemistry class. So you're familiar with this idea. If you buy, what do you buy eggs in? If you go to the store, do you go buy one egg? No. What unit do you buy eggs in? You buy them in a dozen. So 12 has a name, and it is dozen. So you are familiar with the concept that some numbers have a name for them. When you buy socks, do you buy one sock? Even if you're a one-legged man? No, you have to buy them how? And two, which is a pair. And what can two also be called? If it's you and your significant other, it could be called a couple, right? I need a couple of dollars. That means you need $2. So two has 3 names. It could be called two, it could be called a pair, or it could be called a couple, right? Well, this is a number that we go get chemicals in, and it's so important. Like number 2, it has 3 names. And it's called moles. Moles is the unit we use, and it has 3 names. It's also called Avogadro's number, named after Amadeo Avogadro, who is named after. The only picture we have of him looks like that. He looks so crazy with his big eyes and the way he's looking.
Does he have red hair?
You need to just Google him, look him up. Avogadro, Avogadro's number. This will be the picture. And you can see it's like the only picture of him, and he is so funny looking. But brilliant. Absolutely brilliant. So we honor him. But he called it moles, but we want to honor him by calling it his name also, Avogadro's number, and it's equal to 6.02 times 10 to the 23rd. It's a number that's so big we write it in scientific notation. So we're going to have to learn how many moles is in, how many grams are in a mole. Okay, so 1 mole of a chemical is its mass in grams. It's called molar mass, or it is abbreviated MM. So I draw M&Ms. Everybody look at the periodic table. Do you see the blue and the green M&M that I've drawn on my periodic table? You were wondering why I did that. This is why. Where we get the conversion factor for converting moles to grams is the periodic table. Okay, everybody got that in your head? Very important concept. You'll use it the rest of your chemical life. Okay, so here is our first one. What is the molar mass of nitrogen? Okay, so what you do is you go look at the periodic table. I guess I'll pull this one down. I don't think they can see it on YouTube anyway. Let me just get a little one, and then y'all can look at the big one up there. Don't worry, I have periodic tables everywhere. Okay, so you're going to look at the periodic table and find nitrogen. Everybody look up to the top over on the ant side. Do you see the red N number 7? Everybody found nitrogen, that N number 7, it's right here on the periodic table. Good? There are 2 numbers. There's 7, and then there's a decimal number, 14.0067 on this one. Okay, everybody see that? The 2 numbers, the one you want is the decimal number. That decimal number is the molar mass. So, what is the molar mass of nitrogen? We're going to round it off to a whole or a half right now, and we're going to say it's 14 grams per mole. That means if I have 14 grams of nitrogen, then that's a mole's worth. So if I want, that's how I go buy it. I get it, I go weigh it out as 14 grams, because I can't count out millions of atoms. I can't even see them, much less count them. But I have a scale, and I can weigh out 14 grams. Does that make sense to you? Followed it along? Okay, so lithium. Everybody, especially those of you like Ashish, who's right over there, lithium's number 3. Does anybody see the mass of lithium? What is it? Do you see it? It's 6.9. Lithium is Li. I forgot y'all don't know your elements yet. Lithium is Li. It's number 3, and it's 6.9. So if I rounded that off to a whole number, what would it be? 7. So lithium is 7 grams per mole. Somebody look at oxygen, round it off for me. It's number 8 over there. 15.99. What's that going to be? 16. 16 grams per mole. Okay, hydrogen. 1.000. That's going to be 1, right? 1 gram per mole. And water, water's not on the periodic table, but don't worry, y'all know the formula. What's the formula for water? H2O. So we're going to have to add it up. Oxygen is 16, and I have 2 hydrogens. 16 plus 2 is 18. It's early in the morning when honors Kim doesn't know 16 plus 2 is 18 very quickly. Some of y'all needed to have your Wheaties this morning. Okay, so how do we do this problem? We write what we know, and then you write the units of what you want to know in the denominator. Think of a conversion factor, do the math. It's the same way. We'll be doing some problems with this. They're very similar. Because right now, this was all 1, but it won't always be 1 mole. Sometimes I might want to know how many grams is 3 moles. So we're going to set it up and do those problems. Okay, next. For example, how many grams are 4 moles of carbon? We start with what we know. So we write 4, oh, rats. Maybe if I back up, it'll be good. Yay, it is. I feel like Harry Potter. I'm having to write like this. 4 grams of carbon. Okay, what happens to the units? Goes down, right? Let me see here. Oh, how many grams? I did the wrong thing. Y'all ignore that for a second. If you, hopefully you, I'm like, that's wrong. Okay, at least I caught it. Excuse me. Oh, I didn't erase enough. It's very important not to get too enthusiastic about doing your math that you write down the wrong problem. You want to write down the actual problem. How many grams? Grams is the question mark. Are 4 moles of carbon. The abbreviation for moles is MOL, which is kind of funny. Because all you get to do is leave off the E. So 4 moles. Now, where do moles go? Numerator or denominator? Denominator. Oh, I've tutored math to all ages of kids, and little kids will call it the demonator because they're like, it's demonic. Math is evil. Okay, so moles go down here, and what we want goes up here. So what's the conversion factor? Look on the periodic table. Carbon is not 16, go back. It's number 6. 12. So it's 12 grams per 1 mole. Moles cancel out, and I am left with 4 times 12, which is, it started with a 0, 12, 24, 36, 48. I really want to keep going. 60, 72, 84. Okay. Did y'all learn skip counting songs when y'all were little? Yeah, some of y'all did. Okay. So that we stopped at 48 grams. So if I needed 4 moles of carbon, I'd go get 48 grams out of the stockroom. I got a bottle of carbon back there. I could go weigh it out, and I'd have 4 moles. And it's a convenient. Why do we have it? Because it's a convenient measurement. It's about a mole is about a handful for a lot of things. Or I have some moles to show you. It's like maybe like a stick. Okay, so there is the standard. We are not doing the whole standard. We're doing A through E on this test, but we're skipping G and E till unit 3, F and G. G is unit 3, F is unit 4. So anyway, we got a few units on the standard. Okay, so let me show you the rules again for sig figs and sig digs. See how cool I said that? Everybody look at the rules, okay? Adding and subtracting. Here's an example problem. You use all your digits and add it up on your calculator. Now we're ready to round it off. We find which one is the worst number. Which one was measured on the worst piece of equipment, and it's the third one because it only goes to the tenths. Does everybody realize that? So we round it to the tenths. So the 2 leaves the 4 alone, and it's 220.4. Everybody understand adding and subtracting? Okay, now for multiplying and dividing, we have to know how many significant figures it has. That one has 5, that one has 4, because they're all non-zero. Everybody good with that? Now we multiply them, and we need to make it where it only has 4 significant figures, so that means we're going to go to the hundredths. The 2 leaves the 4 alone, so it's 14.42. And here are the rules written out with examples for significant figures also. So you can look at the examples. All right. Are you excited? That was pretty easy, right? That's Unit 1. If you understood everything in it, you're ready for the test. But we'll wait till next Thursday, and we're going to practice and do labs and all that, and sing songs, do some dances. It'll be great. All right. I got to end this. All right. Science is great. Like, share, subscribe.